Space and Science News. With James. Imagine a galaxy so strange, it's challenging everything we thought we knew about the early universe. A cosmic oddball that's got astronomers scratching their heads and rewriting the textbooks. What if I told you that this galaxy's gas shines brighter than its stars? It sounds impossible, doesn't it? But that's exactly what NASA's James Webb Space Telescope has discovered. A galaxy that breaks all the rules, existing at a time when the universe was still in its infancy. This isn't just another space discovery, it could be the key to unlocking the mysteries of how the very first galaxies formed. Today, we'll be talking about this mind-bending galaxy, GS/NDG 9422, because why not? It's not every day we find something that could be the missing link between the universe's first stars and the galaxies we see today. But here's where it gets really interesting. This discovery might just change everything we thought we knew about the early universe. How? Well, that's what we're about to find out. Let's dive deep into the cosmic mystery of GS/NDG 9422 and uncover the secrets it holds about our universe's past, and maybe even its future. In the vast expanse of the cosmos, our understanding of the universe's early days has long been shrouded in mystery. But now, thanks to NASA's James Webb Space Telescope, we're peering deeper into space and time than ever before. And what we're finding is nothing short of extraordinary. Imagine a galaxy so strange, so unlike anything we've seen before, that it challenges our very understanding of how the universe evolved. This is the story of GS/NDG 9422, a galaxy that might just be the missing link between the universe's first stars and the galaxies we see today. Discovered approximately 1 billion years after the Big Bang, GS/NDG 9422 stands out due to its odd, never-before-seen light signature. Unlike typical galaxies where stars shine brightest, in this cosmic oddball, it's the gas that outshines the stars. This phenomenon, predicted in the environments of the universe's first generation of stars, has never been observed in such detail before. The galaxy's stars are incredibly hot, with temperatures exceeding 140,000 degrees Fahrenheit, 80,000 degrees Celsius, more than twice as hot as typical massive stars in our local universe. These scorching stars are heating the surrounding gas to such extreme temperatures that it glows brighter than the stars themselves. This discovery is not just another dot in the sky, it's a glimpse into a time when the cosmos was still young and chaotic. The light from this galaxy tells us a story about how stars formed, how galaxies evolved, and how our universe became what it is today. As researchers continue to study GS/NDG 9422 and search for similar galaxies, we may be on the brink of rewriting our understanding of the early universe. It all started with a faint dot in Webb's field of view. Just another speck among countless others, you might think. But when astronomers looked closer, they realized they were onto something big, really big. Alex Cameron, a researcher from the University of Oxford, was the first to notice something odd about this galaxy's light. "My first thought in looking at the galaxy's spectrum was, that's weird," he said. And in the world of astronomy, weird often means exciting. So what made this galaxy so strange? It wasn't shining like any galaxy we've seen before. Instead of seeing light from stars, the telescope was picking up something else entirely. The gas in this galaxy was outshining its stars. This revelation opened up a whole new avenue of research. Astronomers began to wonder if this could be a common phenomenon in the early universe or if it was an anomaly. The implications were staggering. If gas could outshine stars in this way, what else might we be missing in our understanding of galactic evolution? To unravel this cosmic mystery, Cameron teamed up with Harley Katz, a theorist specializing in cosmic gas clouds. Together, they dove into computer models, simulating scenarios where extremely hot, massive stars could heat surrounding gas to such intense temperatures that it would glow brighter than the stars themselves. Their findings were astounding. The stars in this galaxy, dubbed GS/NDG 9422, must be incredibly hot, more than 140,000 degrees Fahrenheit. That's about twice as hot as the hottest stars we typically see in our local universe. These scorching stars are heating the surrounding gas to temperatures that make it shine with unprecedented brightness. This discovery isn't just a cosmic curiosity, it's a potential missing link in our understanding of galactic evolution. GS/NDG 9422 exists about 1 billion years after the Big Bang, a time when the universe was still in its infancy. It's not quite like the first generation of stars, known as population 3 stars, but it's also not like the galaxies we're familiar with today. Instead, it seems to be caught in a brief yet intense phase of star formation, a cosmic sweet spot where conditions were just right for creating these extraordinary stellar furnaces. This moment in time captures how galaxies may have transitioned from their primordial states into the more complex structures we see today. As researchers continue to study GS and DG 9422 and search for similar galaxies, we may be on the brink of rewriting our understanding of the early universe. Each new discovery brings us closer to unraveling the cosmic story of how our universe became what it is today. Now you might be wondering, how can gas shine brighter than stars? It's a good question and one that had astronomers scratching their heads too. To figure it out, Cameron reached out to his colleague Harley Katz, a theorist who knows a thing or two about cosmic gas clouds. Together they started piecing together the puzzle using computer models to simulate what might be happening in this galaxy. What they found was mind-blowing. The stars in this galaxy must be incredibly hot, hotter than anything we've seen in our neck of the woods. We're talking about stars that are more than 140,000 degrees Fahrenheit. That's about twice as hot as the hottest stars we typically see in our local universe. These scorching hot stars are heating up the surrounding gas so much that it's glowing brighter than the stars themselves. This phenomenon could provide vital clues about how galaxies formed during the chaotic period shortly after the Big Bang. The researchers hypothesized that GS and DG 9422 is undergoing an intense phase of star formation within a dense gas cloud, an environment where massive stars are born at an unprecedented rate. As these massive stars emit vast amounts of energy, they bombard their surroundings with photons, light particles, that excite the gas around them to such an extent that it glows intensely. This interaction between hot stars and gas clouds could be more common than we realize in the early universe. The discovery of GS and DG 9422 is not just a cosmic curiosity, it's a potential missing link in our understanding of galactic evolution. This galaxy exists about 1 billion years after the Big Bang, a time when the universe was still in its infancy. It's not quite like the first generation of stars, known as population 3 stars, but it's also not like the galaxies we're familiar with today. Instead, it seems to be caught in a brief yet intense phase of star formation, a cosmic sweet spot where conditions were just right for creating these extraordinary stellar furnaces. This moment in time captures how galaxies may have transitioned from their primordial states into the more complex structures we see today. As researchers continue to study GS and DG 9422 and search for similar galaxies, we may be on the brink of rewriting our understanding of the early universe. Each new discovery brings us closer to unraveling the cosmic story of how our universe became what it is today. But why is this discovery so important? Well, it's giving us a glimpse into a crucial period in the universe's history. You see, GS and DG 9422 exists about 1 billion years after the Big Bang. That might sound like a long time, but in cosmic terms, it's just a blink of an eye. This galaxy could be showing us a missing link in galactic evolution, an intermediary stage between primordial stars and well-established galaxies like our own Milky Way. It's not quite like the first generation of stars known as population 3 stars. We know this because Webb's data shows too much chemical complexity for that classification. Instead, GS and DG 9422 seems to be caught in a brief yet intense phase of star formation, a time when conditions were ripe for creating massive celestial bodies at an unprecedented rate. Imagine a massive cloud of dense gas filled with newly formed stars hotter and more massive than anything we see today. These stars are pumping out so much energy that they make their entire gas cloud glow like a cosmic light bulb. This moment captures how galaxies transition from their primordial states into more complex structures over billions of years. Understanding GS and DG 9422 helps astronomers piece together how galaxies formed and evolved during this chaotic era when everything was still taking shape, a time when gravity pulled matter together to form stars and galaxies from an almost uniform cosmic soup. The discovery of GS and DG 9422 is particularly exciting because it challenges our current models of galaxy formation. Most galaxies we observe are dominated by the light from their stars, but in this case, the gas is outshining the stars. This unusual characteristic suggests that the stars in GS and DG 9422 are incredibly hot and massive, heating the surrounding gas to temperatures we rarely see in the modern universe. This finding could have far-reaching implications for our understanding of the early universe. It suggests that the conditions for star formation in the early cosmos were dramatically different from what we see today. The intense radiation from these hot, massive stars could have played a crucial role in shaping the intergalactic medium and influencing the formation of subsequent generations of stars and galaxies. Moreover, the study of GS and DG 9422 could provide valuable insights into the process of cosmic reionization, a pivotal epoch in the universe's history when the first stars and galaxies ionized the neutral hydrogen that permeated space after the Big Bang. The extreme conditions observed in this galaxy might have been more common in the early universe, potentially contributing significantly to this reionization process. As astronomers continue to study GS and DG 9422 and search for similar galaxies, they hope to build a more complete picture of how the universe evolved from its earliest stages to the complex cosmos we see today. Each discovery like this brings us one step closer to understanding our cosmic origins and the fundamental processes that shape the universe. This discovery is shaking up our understanding of how galaxies formed and evolved in the early universe. It's showing us the conditions were very different from what we see today. Harley Katz explains it well. It looks like these stars must be much hotter and more massive than what we see in the local universe. This makes sense because the early universe was indeed a very different environment, a place where gravity was stronger and matter was denser. But here's where things get even more interesting. Right now, GS and DG 9422 is just one example among many possibilities yet to be explored. We don't know if this was a common phase most galaxies went through or if it was just an anomaly, a rare occurrence that happened under specific conditions. To figure that out, astronomers need to find more galaxies like GS and DG 9422 to expand their data set and draw more definitive conclusions about galactic evolution during this crucial period. They're actively searching through Webb's observations for other candidates from around the same time frame, hoping to uncover additional examples that could further illuminate our understanding of cosmic history. The implications extend beyond just one galaxy. They touch upon fundamental questions regarding star formation rates and chemical enrichment processes within galaxies during their formative years. If GS and DG 9422 is indicative of broader trends among early galaxies, it could reshape our theories about how matter coalesced into larger structures over time. This discovery challenges our current models of galaxy formation and evolution. Most galaxies we observe are dominated by the light from their stars, but in GS and DG 9422, the gas outshines the stars. This unusual characteristic suggests that the conditions for star formation in the early cosmos were dramatically different from what we see today. The intense radiation from these hot, massive stars could have played a crucial role in shaping the intergalactic medium and influencing the formation of subsequent generations of stars and galaxies. It might have contributed significantly to the process of cosmic reionization, a pivotal epoch in the universe's history when the first stars and galaxies ionized the neutral hydrogen that permeated space after the Big Bang. Moreover, the study of GS and DG 9422 provides valuable insights into the chemical evolution of the early universe. The presence of complex chemical elements in this galaxy suggests that it has already undergone at least one generation of star formation and supernova explosions, which enriched its interstellar medium with heavier elements. This finding has implications for our understanding of how quickly the first galaxies evolved and how rapidly they produced and dispersed heavy elements throughout the cosmos. It challenges our assumptions about the timescales involved in early galactic chemical evolution and may require us to revise our models of how quickly the universe became enriched with the elements necessary for life as we know it. The discovery of GS and DG 9422 also highlights the power of the James Webb Space Telescope in revolutionizing our understanding of the early universe. Its ability to detect such faint, distant galaxies with unprecedented clarity is opening up new frontiers in astronomy and cosmology. As we continue to explore the early universe with Webb and other advanced telescopes, we may uncover more galaxies like GS and DG 9422, each providing a unique piece of the cosmic puzzle. These discoveries will help us build a more complete picture of how the universe evolved from its earliest stages to the complex cosmos we see today. The study of these early galaxies is not just about understanding our cosmic past, it's also about predicting the future of our universe. By understanding how galaxies formed and evolved in the early universe, we can better predict how they will continue to change over cosmic time scales. In conclusion, the discovery of GS and DG 9422 represents a significant milestone in our quest to understand the early universe. It challenges our existing models, raises new questions, and opens up exciting avenues for future research. As we continue to push the boundaries of our observational capabilities, we can look forward to many more such discoveries that will help us unravel the mysteries of our cosmic origins. And that's exactly what Cameron, Katz, and their team are doing now. They're scouring Webb's data looking for more galaxies from the same time period that might show similar characteristics. It's a very exciting time, Cameron says with enthusiasm. We are just at the beginning of new discoveries and understanding. And he's right. With every new image from Webb, we're pushing back frontiers of knowledge while peering further into cosmic dawns we've never seen before. The hunt involves analyzing spectra, the unique fingerprints left behind by light emitted from distant objects, to identify other candidates exhibiting similar anomalies as GS and DG 9422. Each new candidate adds another layer to our understanding of how galaxies evolved during those formative years after the Big Bang. As astronomers delve deeper into Webb's treasure trove of data, searching for signs of nebular light outshining starlight, they're not just looking for isolated examples, they're trying to build a comprehensive picture of galactic evolution during this critical epoch. This ongoing research highlights how rapidly our understanding can change with new technology like Webb. It's opening doors we didn't even know existed before. With each new discovery comes fresh questions that will lead us down paths we haven't yet imagined. The search for galaxies similar to GS and DG 9422 is not just about finding more examples, it's about understanding the frequency and conditions under which these unusual galaxies form. Are they common in the early universe, or is GS and DG 9422 a rare cosmic oddity? The answer to this question could have profound implications for our understanding of galaxy formation and evolution. As researchers analyze more data, they're also refining their models and theories. The discovery of GS and DG 9422 has already challenged existing models of galaxy formation, prompting scientists to revisit their assumptions about the early universe. This iterative process of observation, theory, and model refinement is at the heart of scientific progress. The team is also investigating how these galaxies might have influenced their surroundings. The intense radiation from their hot stars and glowing gas could have played a crucial role in reionizing the early universe, a key event in cosmic history that made the universe transparent to ultraviolet light. Moreover, the study of these galaxies provides insights into the chemical evolution of the universe. By analyzing the spectra of these distant objects, astronomers can determine their chemical composition, shedding light on how quickly the first generation of stars enriched the cosmos with heavy elements. The implications of this research extend far beyond astronomy. Understanding the formation and evolution of the first galaxies helps us piece together the story of our cosmic origins. It provides context for the existence of our own galaxy, the Milky Way, and ultimately, our place in the universe. As Webb continues to collect data, astronomers are also looking forward to future missions and technologies that will complement and extend Webb's capabilities. The next generation of ground-based and space-based telescopes will allow us to push even further into the cosmic frontier, potentially revealing the very first stars and galaxies to form after the Big Bang. In the meantime, Cameron, Katz, and their colleagues continue their meticulous work, analyzing data, refining models, and searching for more cosmic oddities like GS and DG 9422. Their work reminds us that the universe is full of surprises, and that our journey of cosmic discovery is far from over. With each new finding, we come a step closer to understanding the grand story of our universe, a story that began nearly 14 billion years ago and continues to unfold to this day. So what does all this mean for our understanding of the universe? Well, it's helping us fill crucial gaps in cosmic storylines. We're starting to see how our universe transitioned from its earliest days with its first generation of stars into rich tapestry filled with diverse galaxies we observe today. This discovery feels like finding missing pages within cosmic history books. It reveals chapters we've never seen before, a time when galaxies were very different from what we recognize today. And who knows what other surprises Webb might have in store for us. With each new discovery unfolding before our eyes, we're rewriting narratives surrounding cosmic evolution while witnessing birth processes behind celestial phenomena previously inaccessible. As we continue exploring deeper realms beyond mere visual limits imposed by previous telescopes, we're gaining insights into structures forming across vast distances throughout spacetime itself. The story surrounding GS and DG 9422 serves as just beginning. It opens up new questions alongside fresh avenues for research while presenting possibilities regarding understanding origins behind cosmic phenomena. As we peer deeper into spacetime fabric, who knows what other wonders await discovery. This discovery is reshaping our understanding of the early universe in profound ways. It suggests that the conditions for star formation in the cosmic dawn were far more extreme than we previously thought. The intense radiation from these hot, massive stars could have played a crucial role in shaping the intergalactic medium and influencing the formation of subsequent generations of stars and galaxies. Moreover, the study of GS/NDG 9422 provides valuable insights into the chemical evolution of the early universe. The presence of complex chemical elements in this galaxy suggests that it has already undergone at least one generation of star formation and supernova explosions, which enriched its interstellar medium with heavier elements. This finding has implications for our understanding of how quickly the first galaxies evolved and how rapidly they produced and dispersed heavy elements throughout the cosmos. The discovery also highlights the power of the James Webb Space Telescope in revolutionizing our understanding of the early universe. Its ability to detect such faint, distant galaxies with unprecedented clarity is opening up new frontiers in astronomy and cosmology. As we continue to explore the early universe with Webb and other advanced telescopes, we may uncover more galaxies like GS/NDG 9422, each providing a unique piece of the cosmic puzzle. These discoveries are not just about understanding our cosmic past, they're also about predicting the future of our universe. By understanding how galaxies formed and evolved in the early universe, we can better predict how they will continue to change over cosmic time scales. This knowledge could help us understand the ultimate fate of our own galaxy and the universe as a whole. Furthermore, the study of these early galaxies could provide insights into fundamental physics. The extreme conditions present in these early galaxies serve as natural laboratories for testing our theories about how matter behaves under intense gravitational and radiative forces. Any discrepancies between our observations and theoretical predictions could point to new physics beyond our current understanding. The discovery of GS/NDG 9422 also raises intriguing questions about the possibility of life in the early universe. While the intense radiation and frequent supernova explosions in these early galaxies might seem hostile to life as we know it, they also created the heavy elements necessary for complex chemistry. Could life have emerged earlier in cosmic history than we previously thought possible? As we continue to push the boundaries of our observational capabilities, we can look forward to many more discoveries that will help us unravel the mysteries of our cosmic origins. Each new finding brings us closer to answering some of humanity's most profound questions. Where did we come from? How did the universe evolve to its present state? And what does the future hold for our cosmic home? The journey through the cosmic mystery of GS/NDG 9422 reveals that this strange galaxy is more than just a curiosity. It serves as a window into the early universe, shedding light on how the first galaxies might have formed and evolved. This discovery challenges our understanding of galactic evolution, showing us that the early universe was a place of extremes, where stars burned hotter and gas glowed brighter than anything we see in our cosmic neighborhood today. This finding isn't just changing our view of the past, it's reshaping our understanding of how the universe came to be. Perhaps the most exciting aspect is what this means for future research. GS/NDG 9422 is likely just the first of many such galaxies waiting to be discovered. As we continue to explore the deep cosmos with tools like the James Webb Space Telescope, who knows what other cosmic oddities we might uncover. This discovery highlights that the universe is full of surprises. Just when we think we've got it figured out, something comes along to shake up our theories and push our understanding further. It's a testament to human curiosity and the incredible technology we've developed to explore the cosmos. Thank you for joining me on this cosmic journey. If you enjoyed this video and want to stay updated on the latest discoveries in space, don't forget to hit that subscribe button. If you have any thoughts or questions about GS/NDG 9422 or early galaxy formation, leave a comment below. Your question might inspire our next video. Until next time, keep looking up and wondering about the mysteries of our universe. There's always more to discover. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.